done in the previous example, an interesting case arises when this force is suppose 40 Newton instead of 100 Newton. Rest all the things they are same. They are same blocks, 30 kg, 10 kg, 10 kg on a horizontal surface. Coefficient of friction between these blocks and the surface is same. Now we are supposed to find what are the value of friction forces between these surfaces. So over here we see that is the limiting value of friction force as we had calculated 10 Newton here, 10 Newton here, and this is 30 Newton here. So that is 30 plus 10 plus 10, that is 50 Newton. The force which is trying to move the blocks is 40 Newton. So obviously this force is not sufficient enough to overcome these forces. So it means now the blocks will be stationary. It is not that the blocks will start moving this way. We can't do it. That is 50 Newton is this way, 40 is this way. So 50 minus 40 is equal to mass into acceleration. We cannot do it because when we are pulling these blocks in this direction, so the blocks can move only in this direction. It is not that we have pulled the blocks in this direction and they start accelerating in this direction. That doesn't happen. Blocks, this force, because of this force, the blocks will have a tendency to move only in this direction. Either they move in this direction or they don't move. That is the only two things which is going to happen. It is not the block starts moving in this direction. So it means that is these forces, this plus this forces, they can't be total 50 Newton. So it means when these blocks, they are stationary and 40 Newton is being applied over here. So it means this force and the force at this interface, that should add up to 40 Newton only. That is the friction forces, they should be 40 Newton and that should be a case of self-adjustment. Now we have to think about that is where which force is going to self-adjust, at here, or at this interface. Where the forces they are going to self-adjust. To understand this, that is which force is going to be adjusted, let's understand it is through a simple example where we have a 10 kg block, mu is 0.1 and over here we have a 5 Newton force. We know that is mu into n, that is limiting value of friction force is 10 Newton. So this force is going to be self-adjusted with the limiting value of friction force is 10 Newton. So this is going to be self-adjusted with this friction force. So even if we tie a string to this, it will not have any tension because this force is going to be adjusted by this. So friction force says, it's something like it says that is first overcome me, then the rest of the force I can transmit over here. And this force is not able to overcome this force. So as a result, the tension in the string is going to be 0. But if we make it as 15 Newton, then friction force says that is your value is much greater than my value, which is maximum value of friction force. So now I'll try to stop you with my maximum height, that is this will be 10 Newton. But because of string, this block will not be moving in this direction, but it will still be stationary, it will still not be accelerating. So it means T is in this direction, this is not accelerating. So 15 Newton, it has to be equal to 10 plus T. So now T comes out to be 5 Newton, tension will be 5 Newton. So what happens is, when you apply a force from here, this friction force says, first overcome me, then only I'll transmit the remaining force over here. Similarly over here, when we look at this one, we draw the free body diagram of this one, we say T1 is here, T2 is here, and let's say T2 is here. We are not writing what the value of friction force is. This is 40 Newton. So friction force over here, it says that my maximum value is 10 Newton. Your value is greater than my value, so I'll try to resist with my maximum height. So this is going to 10 Newton. But we have seen that the whole system is not moving, that is acceleration of all the blocks, that is equal to 0. So it means acceleration of this is also equal to 0. So it means if this is 10 Newton, this has to be 30 Newton. 30 plus 10 is equal to 40. So if this is 30 Newton, so it means this is going to pull this with a force of 30 Newton. If this is 30 Newton, then once again, the friction force over here, it sees that is okay, you are 30 Newton, but my maximum value is 10 Newton only. So your value is greater than my value, so I'll resist you with my maximum height. So this becomes 10 Newton. When this becomes 10 Newton, once again this system is not moving, this is acceleration is equal to 0, acceleration of this block is also equal to 0, the resultant force on this block is also equal to 0. So this is 30 Newton, this is 10 Newton, so this comes out to be 20 Newton. So it means that this block will, through this string, will apply a force of 20 Newton onto this block. So once again, when this 20 Newton is being applied, this will try to move it this way, so friction force will come into play. Limiting value of frictional force over here is 30 Newton. The force which is trying to move this block in this direction is 20 Newton. This limiting value of frictional force is 30 Newton. So as a result, this friction force is humble enough. It says you are 20 Newton. I cannot go beyond 20 Newton. So as a result, this adjusts itself to 20 Newton. So now the forces, the friction forces at their lower surfaces will be 10 Newton, 10 Newton and 20 Newton, 20 plus 10 plus 10, that is 40 Newton. So 40 Newton is in this direction and 40 Newton is in this direction. Net force along the x-axis on this system is equal to 0, and this is a stationary system.